Now that Grace and I are back from the Builder Show and we're about to go to the AHR Expo and we're finishing up with the enclosure stuff on this house that we're building for our family, it's time to start really digging into the HVAC. So as far as our HVAC systems go, we're going to have Mitsubishi electric heat pumps, a ducted split system that's a 1.5 tons in the main body of the house, and then a ductless mini split that's a 3/4 ton in the studio. We're going to have 2 dehumidifiers. Of course, we've got 2 spaces, and if you are familiar with this house, it's kind of weird. So you want to take a look at those other videos. But the 2 different spaces are going to have an MD33, which is a new in-wall 33 pint a day dehumidifier in the studio space, and then 105 pint a day dehumidifier in the main space. We're going to have a Fantech ventilation system, which is totally off the wall, and you need to see that 23-minute long video just to understand how that works. And then we're going to have some fans moving things around. And so all of that is going into these crazy thoughts that are now starting to bounce around my head, because of course it's not just building science theory that is important at this point. We are actually building a house. So how exactly we're going to do all of this, as far as the duct design, the layout, and everything like that, is really what matters at this point. So we tuned in with Bryan Orr, who is my friend and the creator of the HVAC School podcast. And if you don't know that show, after you watch this video, you're going to want to go over there and get all that content, because he's an amazing person. Here's what he had to say.
I guess let's start with what your realistic hopes are as far as a homeowner, and then what your idealistic hopes are as far as an influencer who wants the world's perfect home. Because it is, those two things are in conflict. Like I have in my own house, I have very low velocities, very low face velocities on my vents. So much so that any true AC designer would be like, well, this isn't right. You're not going to have good air mixing. But guess what? I feel great in my house. So, what's the problem? But there is some truth to it, obviously. So you talked about the Coanda effect. And is that how you say that? I've never actually heard anyone say it, so I've only read it. Is it Coanda?
I don't know. I just say laminate it to a surface. So basically, like, just background for people who are watching us do this banter. First of all, both you and I read, and we also write, and we talk, and we, form kind of little sayings that people then repeat.
Right.
And I think that's all great. But I'm sitting inside of a building that is actually being built.
Right.
And, taking the idealistic pie in the sky thing, as you mentioned, and trying to make it real life is the thing. And your example of like low velocity doesn't necessarily equal uncomfortable. And also knowing that, like, for me, building a super airtight house, when I have kids, they're going to open and close the door maybe 100 times, and you've got 10 kids. So your house doesn't even, like, why are we even?
Right.
So anyway, I think that the real life thing, and that's why I wanted to turn to you, because you run a company that does home services.
Right.
You know what systems actually perform like. And just because something is oversized doesn't mean it's going to not produce a house that is dry enough. It could, through a variety of factors, end up being that. So basically what I'm confused about here is I've got so many different systems going on. We've got, first of all, heating and cooling, which everyone needs. We have point exhaust, but the point exhaust in the kitchen is the only one that's going directly outside, the dryer, I guess, also. All the other point exhausts in bathrooms are going to go through the ERV to connect up to the supply ventilation that's coming in separately ducted into the bedrooms. So now I've got 2 duct registers in a bedroom just for supply, one for outdoor air and one for conditioned air.
Right.
Should those be close together? Should they be far apart? Does the velocity of either of them matter if I have a ceiling fan that I expect to be running at least on a low speed in an energy efficient mode? So I guess those are the kind of things that are now rattling around in my brain. And I think that, for example, like here, we've got this room, and I'll be flashing the plans up for the people who are watching. You're looking at them on your screen.
Mm-hmm, yeah.
But we've got a big room. We have 16-foot high ceilings over here. We've got 10-foot high ceilings over here. It's 36 feet long, 24 feet wide. It's kind of 2 spaces based on an architectural aesthetic separator. But should I have floor registers, which I'm not really in favor of because dirt and dust can get down in there?
Right. Or
should I shoot for ceiling, like try and get them as close to the ceiling and have them laminate to the ceiling surface? Should I go low? Does it not matter? I guess these are the kinds of things that should I try and split them up? So instead of giving one 100 CFM flow, I give 250s. So I guess just from your practical years of experience running a company that does this kind of thing, and I know that design is not your particular specialty within the company, what are your kind of thoughts about approaching this?
Yeah, so I mean, there's a couple things. First off, most of the houses that have been built over the last forever, I guess, over the last forever, are built with fairly high velocities, or can be built with fairly high velocities, because you have larger systems. A lot of systems are fairly oversized or have fairly high loads because they're not as tight or not as well insulated. And so as you get, the first thing I think to recognize here, and you're right, I think in terms of very practical, I can design, but it isn't actually my strength. I think in terms of just like what works or what doesn't work and how to think about the relationships between things. But as you start to put less air into a room, by very nature, you're not going to get as much mixing. So it's a challenge with high efficiency homes. And if you have, say, a room that in a traditional home maybe would have 150 CFM, it's much easier to get that mixing in the air when you're moving more of it than it is when you have less of it. And so I think it's smart the way that you're thinking about this, which is that if you use, say, high efficiency fans with low fan speeds, you can deal more with that mixing using that fan, and also better destratification, which is another nice thing. So you start to get all of your surface temperatures in the room near the same temperature versus having, maybe a hot ceiling, kind of a thing where you have that effect of hot air rising in a room, for example. I think that's a smart way of looking at it. Is the Coanda or Coanda? I don't know how to say it correctly. Is that a real thing? Absolutely. And that just simply is when you run an airstream across the surface, it increases its throw. And that's because of Bernoulli's principle. So there's the low pressure space at the top, and it kind of sucks it to that ceiling or potentially even a wall, and it allows it to travel further. And of course, you're going to have that effect if you were to use the ceiling. And that's true whether or not you have very high airflows or low airflows, just by adjusting your diffuser size or your grill size to get that face velocity where you want it, based on the throw that you want. That is going to increase as you run across that surface. But obviously, it's diminishing returns. As you get to the point where you have less and less airflow, that becomes more and more difficult because they don't make these tiny little, tiny little vents. That's not going to probably be practical. I mean, you can use a linear, like slot diffusers, those sorts of things, but then those tend to go straight down. So from a very practical standpoint, my perspective is that if you control the humidity in the space, you are mixing the air in some way, whether that's by using vents that are going across the ceiling and are mixing very well because of the velocity of the air themselves, or by using ceiling fans. As long as you're controlling the temperature in the space, you're controlling the humidity really well, which that's always the thing I care about most. You're controlling the mixing, and you're looking at the temperatures of the surfaces, because that's something that often gets lost in the mix, is that even if the room is nice and cool, but the ceiling itself is hot, that affects our body's comfort, because we are affected by that radiant gains from that ceiling. So as long as you're looking at all of those things, I think you're going to be just fine. I mean, like I mentioned, I have a very large room, which you've been in, which is probably similar to what you've got there. And I have metal exposed spiral duct that runs through it, and it has essentially side diffusers, side grills coming out the side, and they're very low velocity. You can't hear it when the air is running. It's very low velocity, and it's perfectly comfortable in my space. The mixing, actually, I don't have any ceiling fans. The mixing probably isn't great, but because we're controlling that humidity, we're controlling that temperature, and we're fairly well insulated, so we don't have, hot walls, hot ceilings, that sort of thing. It's really still quite comfortable. And
actually, at home chem, it became apparent. One of the building scientists at the home chem experiment said that when people move through a space, it actually does a huge amount of mixing. So when you got 12 people in your house all moving around all the time, I know how much time you guys spend in that room. I would wonder if that actually has a huge effect on that.
Sure. And another piece is also, another piece is just loads that occur because you have more people. We do things like we're running the kitchen exhaust a lot, and we're running bath exhausts, and we're opening doors a lot more, and we're moving around. And in one sense, that's a bad thing because it is bringing in more outdoor air. There's more moisture load. But from a mixing standpoint, that may be one of the reasons why we have less issues. You don't have that feeling of hot spots. other than when you are, because my front wall actually isn't as well insulated as some other things, and I've got my windows. If you're sitting right there, you're affected by the radiant from the wall, and that's why I would almost say that you don't have to get everything perfect here. And my list of things that I want us to control: first, humidity; second, temperature; probably even third, looking at the radiant effect; and then fourth, I think mixing. That's sort of my hierarchy of Bryan's hierarchy of needs and comfort.
Awesome. I like that. So then it's probably overthinking it if I think about the fact that we've got the ventilation system I already described. The dehumidification system for the house is going to be a 100 pint a day dehumidifier for the main body of the house. And that is going to be collared into the HVAC system just like a filtration system is going to be. Okay. Should I go, does it matter what order the filtration versus the dehumidifier goes in, or is it just put them in there and it'll take care of itself?
That's something that I would have to think through and see specifically. Okay, so what you're saying is you've got your filtration system that's dealing separately from the HVAC equipment completely. It's just
we'll have a filter in the unit, obviously, for just equipment safety, but then we're going to have a HEPA filter that's only filtering some of the air. It's not able to get all of the 800 CFM for our 2-ton system filtered at the same time. So it's going to take some, as continuously as the thing runs.
Right. Okay. That's pretty exotic. I mean, that's pretty cool. Yeah. It shouldn't matter. So to answer that question, it really shouldn't matter. Whenever we're thinking about dealing with outdoor air, we have to really think about the dew point of that air before we inject it into an airstream. That's really the main thing, is that anytime you're moving air that potentially has high dew point, no matter where it comes from, but that's generally going to be outdoor air, we have to think very carefully about where are we putting that, and is it possible for that air to achieve dew point when it is injected into that airstream. But it doesn't sound like that's a concern here. So I think you're safe to put it in wherever.
Okay, great. So yeah, I think that, and you're, by the way, it's just so everybody's clear, Bryan is in Florida, in Central Florida. And so yes, it gets very humid there, but remember, it gets humid everywhere. Even in Alaska, it's, hot and humid for a week. Maybe they don't have to worry about that. But so the other question that I had for you is, do you think that it would be better, what we did in the tiny lab was induce a pressure differential. So we put fresh air into the back and sucked the air in from the front to induce the air to move across in like a kind of a tidal pattern. And normally this happens, like you put a supply in a bedroom, but the return in the hallway so that it kind of like forces the air to do that. If I use that on both the heating and cooling system ducting and also on the ventilation ducting, to try and really kind of play that pressure differential game, is that like a better thing than not doing it? Would that help the mixing to the point where, should I return my filtration air and my dehumidifier air from different places than where the heating and cooling ducts are returning from?
Yeah, I mean, it certainly can't hurt. And again, this kind of follows the issue of diminishing returns as that amount of airflow that you're moving is less and less. And none of these systems that you got going on are moving large amounts of airflow. So when you compare that to the total cubic feet of air in that space, and you kind of look at that air changes formula, what you'll start to realize is that you're really not moving that much air. And so is it better? Sure. It's always better to move air within a space without creating a significant enough pressure differential that it's going to result in, losses. And so this is partially, you can get away with some of this stuff, partially because you're building so tight. In a loose house, whenever you create pressure differentials, you run the risk of it drawing in around every gap and crack that exists. And so it actually becomes a risk when you depressurize one area and positively pressurize another, because in that negatively pressurized zone, some of that's going to come from the positively pressurized zone, but some of it's going to come from outdoors, can lights, attics, crawl spaces, all that sort of thing. So that's an undesired result. In your case, because you know that you have such control over the envelope, it's safe to do it, and it's certainly not going to hurt anything. So long as you're not doing it in an isolated area that's maybe separated by a door or something like that. I always have to be careful. If you never want to create these pressure differentials, across an isolation point like a door.
Right.
But so is it? Would that be best? Sure, as long as it's practical. That makes more sense. But sometimes people do this at the expense of another thing. I ran into this with a duct design recently, where somebody was designing ceiling vents, and they were putting them to the outside of the house because up north, that's often how you do it. You're thinking you want to, because again, they're generally coming from the floor or traditional, baseboard heat or radiators, those sorts of things, and they want to radiantly cool and heat that wall. And so they were trying to do something similar, but it didn't make sense because you were running longer ductwork. And it was an unconditioned attic. So it was a silly thing that they were doing. They were running longer ductwork in order to try to get a slightly better duct design or ventilation design, but at the expense of having more ducts, which is a problem because now you have thermal gains in the ducts. So I wouldn't do it at the expense of having to try to figure out how something's going to fit or running it at a significantly longer duct or anything like that. I would do it as it makes sense with the design of the home.
Okay, great. And so, but not so short, like to have the return right on a wall and then the blower right there, obviously.
Right. You always want to think about, you want to think about these things again, you become a master of the obvious before you start getting exotic with things. And you see this so often where people, they miss the really obvious things that an infant could come and notice. Okay, maybe not an infant, maybe a toddler. I don't know. But
I'll check that out. I'll try it out.
Try it. Yeah, absolutely. Yeah. So that's something that you want to really be cognizant of. And it's the same thing. It's just as simple as I saw this just the other day. We went to a house that was they'd spent all this money on building performance stuff. They had an ERV and they had a ventilating dehumidifier, and they made all these changes to the duct system and all this. Well, in the process, they had an intake for the ERV right over top of a tankless water heater. So outside, tankless water heater, and then you go inside, and they had a gas range that was not vented to the outside of the home. And this guy has spent, I don't know, $25,000 on building performance upgrades. And it's like, come on, man. I mean, like we could have vented that range, and he cooks, and it's not like they don't cook either. He cooks all the time on it. That would have been the first thing to do, not the last. And that's what happens so often is we just, we got to think about where is this air coming from? If we're bringing in outdoor air, where's it coming from? Where's it going to? Not putting supplies right next to returns and stuff like that. You just think about obvious things.
Right. And I think that's why talking with you about this stuff makes me feel better, because the science behind it is like, oh, everything should be, we'll take turning vanes inside the ducts, everything. Right. And then I've got literally like right up there, I have beams inside my floor that are that thick that I'm not allowed to drill through any bigger than an inch. Right. No ductwork can go through my floor this way. Right. And so now it's like, well, and that's partly why I've never done duct design. I do manual J, load calculations, but I'm not going to touch ducts because I'm not installing the ductwork. I have no idea what's going to actually be there when it's done. So I think, it's things like, for example, should I use flex duct for the last 3 feet in your knee-jerk opinion? Is that like an always yes thing just to get sound reduction?
I mean, how much do you care about sound? That's another thing. So like, is that a really big deal to you? If it is, then yes, because will it make a slight difference? Yes, it will make a slight difference if you're measuring it with a decibel meter, but is it going to be in a high ceiling where it's far enough away that you're not going to observe it anyway? Then that's another consideration. If you're going to put it in the ceiling and it's not going to be anywhere near where you're worried about it, well, then there are disadvantages to doing that. Like you are adding flex to a system that's otherwise designed out of metal, and we all know the advantages to that, especially if you ever want to clean it, that sort of thing. So it just depends on what you're wanting to accomplish, and it doesn't fall into the category. See, there's some things that fall into the category of like malpractice, where you would never do on anyone's home, even if it's yours, because you sell it someday and somebody else has it. Sometimes I might have committed that on my own home. It's like it's my house, I can get away with it. But so there are categories of things like that, like for example, installing a gas furnace in a way that's going to be dangerous or something. But a lot of this just comes down to preference. If you care more about not having any of that flex in your house, that evil flex duct in your house, well then great, just don't install flex and just deal with the fact that there might be a little bit more noise. When you have people who are designers who are designing for others, then yeah, it's a good idea, because you want to do things by best practices, so that way if later somebody else comes back and says, well, this is noisy, you can say, well, it was installed all according to industry best practices and you're just being crazy, like, not that you would ever say that, but that's what a designer has to consider. But when you're thinking through it yourself, I would probably be prone to not use flex if I was going to do a metal system.
Right. So probably just like anything in life, everything in moderation. And a lot of the tropes that I have been, talking about, like, oh, you want to reduce the sound and everything. If you're using, we're going to put a Mitsubishi split system in here. It's already quiet. It's like 35 dB. So yeah, I guess now that you're mentioning it, why am I trying to quiet something that's already library quiet?
Right. And that's a reason. So one of the things, gas furnaces are historically noisy, like even compared to fan coils. They're just, they're noisy as heck. And I don't know exactly why that is. It especially tends to transmit down the return because the blower's on the low side. And so you get a lot of transmission noise there. And I think that's the reaction, because most of the country has gas furnaces. And so they're dealing with that. But even with fan coils, I just don't see it as being a real issue. I think a better way of looking at it is from a practical standpoint. Sometimes it makes a lot of sense to use flex, because that last few feet, it just makes it easier to position things. And when you're trying to take it into your boot using all metal, sometimes that can be challenging. And so I think that's a very valid reason to use flex. Sometimes it's helpful to be able to take a nice little curve or swoop going in. And the whole hatred of flex that exists, I'm definitely not on that spectrum either. I think flex has a great role in the industry. It's very useful in a lot of applications. And if it's installed properly, it works perfectly fine. My house is made of Borden Flex, the evil Borden Flex in my house. And guess what? It works perfectly fine. And I have good filtration, and there's just no issue. It's just not a problem. But it all comes down to how it's applied, how it's installed, and what you want, because there is a lot to be said from a cleanliness standpoint for not using anything that's corrugated.
Right. And it's not just about what you and I want, really, right? We're both married, and we know that it's really more about what our wives want.
Absolutely.
So now that you've lived in your house for a few years and you've got this exposed ductwork, I don't know if you had to talk Leilani into that, but now that you've been there for a while, is exposed ductwork something that your family has grown to enjoy? Should I try to talk my family into that? Or?
I mean, I think that's just personal preference. We always loved the idea. I don't know about like Margot, she was a baby at the time, so I didn't ask her, but no, we've always loved it. I always loved that sort of industrial feel. And so did Leilani. So, that's why we hung out an aircraft cable and all that to make it kind of have that vibe, that loft vibe. And so if you like that vibe, then by all means do it. I think it's just a design aesthetic. As far as from a technician standpoint, one of the reasons I did it, and this is super nerdy, is so that I could test and I can go in and do my, my induct, anemometers and things and do tests and videos and all that. And so that's a very impractical reason that most people wouldn't want. But exposed ductwork all comes down to practicality and whether or not you like the aesthetic, but it works perfectly fine.
Okay. Awesome. All right, great. Well, I'm gonna take more advice from you and incorporate it into the duct design that I'm gonna make a separate video about. So for those of you who are watching, first of all, go check out Bryan's YouTube channel, check out his podcast. He's got so much information that you could drown in it if you want to. But also make sure that you stay tuned to this project, because there's gonna be a lot of things that we're incorporating from Bryan's expertise. And you're gonna see him here because he's coming to help us install this thing. So I'm very excited about all that stuff. Bryan, thank you so much for taking the time today. And we hope to see you down here soon.
Absolutely, I'm excited. Thanks, Corbett.